Okay, for this problem we're finding the force on this charge, Q2, and we're going to call this, I'm sorry, Q1. We'll call that Q1, we'll call this Q2, we'll call this Q3. And just like the previous problem, there's a force on Q1 due to Q2, and there's a force on Q1 due to Q3. So if I think about those forces, if this is positive, and this is positive, and this is negative, then this charge is going to push this charge away along the direction, along the line that connects these two charges, and this charge is going to pull the charge towards it. So these are going to be the two forces that are acting on my charge Q1. And notice that this charge, or this force right here, has x component and a y component, whereas this force right here only has an x component. Okay, so we have to use the superposition principle, meaning that the forces on charge Q1 are the sum of the force on Q1 due to Q2 plus the force on Q1 due to Q3. Alright, so that means that force on 1 is equal to force on 1 due to 2 plus the force on 1 due to 3. Alright, so let's find the force on 1 due to 1 first. So the force on 1 due to 2 is equal to K Q1 Q2 over R 1 2 squared. If I look back at the picture, R is this distance here between Q1 and Q2, and so that's going to be 0.5 meters. This is a equilateral triangle, meaning that all the sides are equal, and these angles, each of these angles is equal to 60 degrees. Okay, so I'm going to have 9 times 10 to the 9th Newton meter squared per Coulomb squared times 2 times 10 to the minus 6 coulombs times, I think it's 7, yes, times 7 times 10 to the minus 9 coulombs. I'm sorry, minus 6 coulombs. Let me erase that. Minus 6 coulombs, all divided by R12 is 0.5 meters squared. Okay, and when I plug in those numbers, I find that F12 equals 0.504 newtons. So that's the magnitude, or the length, of this vector right here. This length right here. I'm sorry. This length right here is equal to 0.5 meters. I'm sorry, this length, we're finding the length of the force. So it's the length of the force that represents the magnitude of the force, or how big the force is due to that charge. Okay, and now I want to find, let's find F13 over here. So F13 is equal to K Q1 Q3 over R13 squared. And when I plug in those numbers, I find that the F13 is equal to 0.288 newtons. Okay, so now I figured out on this charge Q1, I have a force that looks like this, and I have a force that looks like this. And so now I need to add, how do I add them up? So I need to find the x component, and this is F12. I need to find the x component. This would be F1x. I'm sorry, 12x. Erase that. Oops. Well, let's see if I can just work with that. F12x, and this is F12y. Okay, so how do I find F12x? Well, if I think back to my triangle here, I've got a triangle, and this angle here is equal to 60 degrees. So these two angles are equal, and this angle then is also equal to 60 degrees. And my F12x here, this x component of F12, is adjacent. Remember cosine of 60 is equal to adjacent over hypotenuse, and that's equal to f(1,2)x over f(1,2). If I multiply both sides by f(1,2), I find that f(1,2) f(1,2)x is equal to f(1,2) times cosine of 60. In the same way, f(1,2y) here is also a component, and this one is opposite. So opposite is sine. So I find that f(1,2y) is equal to f(1,2) times sine of 60 degrees. Oops. Okay, and so if I notice my f(1,2x) is in the negative x direction and my f(1,2y) is in the negative y direction. Alright, so to find my total force, I need to find my total force in the x direction and my total force in the y direction. So let's do x first. In the x direction, I have a negative f(1,2x), because remember that's to the left from my what we just did, plus f(1,3), and that's because remember my charges. My charge here is pulling my Q1 to the right, and so that's a positive. And so that gives me, I have, when I work out f(1,2x) is f(1,2) cosine theta, this becomes 0.504 newtons times a half. So I end up here with negative 0.254 newtons plus plus 0.288 newtons. And so the final for that will be whatever we'll have to add that together. I think it's 0.034 newtons. And now FTY is just the f(1,3). I'm sorry, it's just f(1,2) y cosine theta. And so that equals 0.44 newtons. So now we have our ftx and our fty. So to find the magnitude, we take ft is equal to the square root of ftx squared plus fty squared and we find that this is equal to 0.438 newtons. And to find the angle, theta, we have theta is equal to tangent inverse of fty over ftx. And so we find that theta is equal to 85 degrees. And does that make sense? Let's draw for our, if this is my charge, Q1, then I have an x that looks like this, and I have a big y compared to x. So I would expect my total to look something like that. And this would be the angle measured from the positive x-axis, and so that's that's 85 degrees measured from here. So it would be a negative angle here. So when you measure, if I were to draw my x-axis, when I measure this way, that's positive, and when I measure this way, that's negative.